In this video, we're going to learn how to balance redox reactions using the half reaction method, but in basic solution. Right, in prior videos, we have learned how to balance redox reactions with the half reaction method, but using protons to balance the hydrogen atoms in the reaction. That works well if you're working in acidic media, but if you're working in basic medium, then that procedure is not correct. Okay, so let's try to see how that would work for a basic solution. We're actually going to do this using an example as opposed to just enumerating the rules. All right, the reaction that we're going to try to balance is silver reacting with cyanide and then oxygen to generate a silver cyanide complex ion, okay, which is that one. As always, we start by identifying the species that undergoes oxidation and the species that undergoes reduction. All right, the oxidation number of silver is 0, it's elemental, and then that means that here oxygen is also elemental. Looks like the cyanide doesn't undergo any change, right? You still have the same cyanide, so that doesn't undergo any redox process. Right, when we go to products, this silver is equal to +1, so that is obviously the oxidation process. Okay, we go to the oxidation process, and we find that that is going to be silver going to this silver cyanide complex. Right, notice that there's no way that I can balance this unless I include also that cyanide ion in reagents. Okay, so let's actually put it right there, Cn minus. Okay, and then the reaction would be oxygen going to, well, we don't have any products right here, but we can surmise that that is going to be water or protons and so forth, okay, which is not explicitly in the statement. All right, so let's start balancing here this reaction. And we go to the oxidation, and then we have that the only thing that we have to do atoms-wise is to place here a 2, and then we have all of the atoms balanced. We still have to balance the charges. Here we have 2 negative charges. There we have only 1 negative charge, so we add 1 electron, and that does it. Okay, so that is the oxidation reaction balance. Now let's go to the reduction. The reduction here, to balance the oxygens, well, we also we can use water. Okay, that is what it is. And then the way to balance these hydrogens is with protons, H+. So until now, we actually haven't changed anything. Okay, this is exactly the same way as we're balancing it in acidic media. All right, and then the final step here is to balance the charges by adding electrons. Okay, notice that to balance that, you need 4 electrons here. Okay? All right, so here we have 1 electron in products, here we have 1 electron in reagents, so we need to multiply that by 4 in order to balance those half reactions. And then what you get at the end of this is going to be 4 silver plus 8 cyanides plus O2 plus 8 protons. 4 protons, and then you have 8 electrons that cancel with the 8 electrons, and the products are going to be the silver cyanide complex, and then 2 molecules of water here. Alright, so again, this reaction will be balanced. Actually, I'm forgetting here 4 for this silver. This reaction will be balanced if we were working in acidic medium. So this is where the basic medium balancing comes into play. Now, to remove the acidic medium, what we can actually do is neutralize those protons that we have right here. And we can do that by adding as many hydroxides as we need to reagents and products. Okay, so here, if I add 4 hydroxides, I'm neutralizing those protons. But if I add 4 hydroxide right here, then I need 4 hydroxides here. Right? And in this way, I haven't changed anything about the reaction, it's still the same reaction. Okay? Now notice that when you combine 4 protons with 4 hydroxides, you're going to generate 4 water molecules. Okay, that is where the neutralization comes in. And then the reaction will be balanced. We just have to keep track of the fact that here you have 2 water molecules, here you have 4, so that is going to end up in 2. Alright, so our final reaction is going to be equal to 4 silver plus 8 cyanides plus O2 plus 2 waters to generate 4 of the silver nitride complex ions, and then 4 hydroxides. Okay, let's double check that this reaction is well balanced. Silvers, we have 4, and we have 4. Cyanides, we have 8, and 4 times 2 is 8, so that's balanced as well. Oxygens, we have 2, and 2, 4. 4, that is balanced. We have 4 hydrogens, that is balanced. Let's now look at charges. 8 negative charges, and then we have 4, and 4, 8 negative charges. So the reaction is well balanced. Again, so the only difference between balancing the redox reaction in acidic medium and basic medium is that you proceed as if you were going to balance this in acidic medium. But at the end, what you do is you neutralize the protons that you have either in reagents or in products by adding hydroxide to both sides of the equation. That gives you water, which neutralizes that, which is the product neutralizing that acid, and that leaves some hydroxide in solution. Okay, which means that again, that will be how the reaction looks like in basic medium.